Alright, so we're going to take a look at graphing members of the exponential family. So if you haven't looked at the previous video, the 4, 1, C, and D, go ahead and look at that before you watch this one. We're going to sketch the graph of each function and state the domain and range. Now, in order to take a look at graphing members of the exponential family, we're going to take a look at a very familiar function, which is the parabola. So I want you to remember that when we graphed parabolas and we actually looked at transformations of them, if you'll remember, tacking on something like a +1 to that parabola just moved it up 1 from the origin. Remember that? And if you can remember that basic transformation of something that's familiar, or at least more familiar to you, a parabola, more familiar than an exponential function, then really remembering thinking about what to do to the exponential function is really not that bad. So because the 1 is tacked on with a plus or minus at the end of the function, or it could be at the beginning, but in other words it's not in with the x, then we know that that's a vertical adjustment, and it's a vertical translation. Okay, it's vertical because it's not in there with the x. So let's take a look at what this graph would look like, and then we're going to just do the same thing with the exponential function 3 to the x. We're going to move it up 1. Well, let me get the basic graph in there. I know that if you want to make a table, you can, but I'm not going to do that. I'm going to go 1/3 over 0 up 1, over 1 up 3, and then over 2 up 1, 2, 3, 5, 6, 7, 8, 9. There's the basic graph. I'm going to leave the basic graph dashed. There's my, when I say basic, there's the kind of the parent graph, if you want to call it that, a parent graph. Some books call it a parent graph that way. Now, what I'm doing is I'm going to move it up 1. In other words, every point is going to be moved up 1. So let me just take all my points that I actually have graphed and move it up 1. Now, this right here in this area here is going to approach the a horizontal asymptote of y equals 0. So when I move this up, it's also going to approach a horizontal asymptote, but it's no longer at 0. Where is it? You know, it's at 1. Y equals 1. And so there's my adjusted graph. Okay? And there is a horizontal asymptote. I'll make that horizontal asymptote a dashed line in a different color. Now, let's take a look at the domain and range of this adjusted function. Okay, the domain in this one, oops, sorry, I'm trying to be consistent with my color. Domain in this case is -infinity to infinity, no big deal. But the range, right, has been moved up 1, so we're going to start at 1 and go to infinity. Notice we're not including the 1, okay, because it never approaches the 1. It approaches it, never reaches it, excuse me. All right, let's take a look at another one where there's more transformations happening to it. And again, I'm going to start with the familiar parent graph of a parabola. Now, what I'm going to do is I'm going to make a horizontal adjustment. Now, that was a vertical, right? When we see a horizontal adjustment, remember that's when it's happening, the adding or subtracting is happening inside with the x. In other words, it could be in the parentheses, it could be inside the radical. If it was a square root function, it could be inside the absolute value bars if it's an absolute value function. But if it's in there with the x, then it's a horizontal translation, some way, this way or this way, horizontal translation. So let's just say that I had the -1 just like we have up here. Then, excuse me, then this is going to be a horizontal slide one way or one to the right or left. Now remember, when it's horizontal, we always do the opposite of what we think would happen. Look back up here. This was a +1, and so it moved it up 1. That's consistent with our intuition. On this one, it's going to be opposite of what our intuition says. If -1 would normally, we would think of going in the negative direction, 1 space. That's not what it's going to do. It's going to go in the opposite direction, so it's going to be moving to the right 1. Now, let's go back to this right here. And remember, there's my parent graph. I'm going to go ahead and put the parent graph on there. In other words, the one that doesn't have any adjustments to it. So that's going to be a 1/5, 0, 1, over 1 up 5. Notice the larger the base, the more quickly it turns. And then I'm not even going to be able to put the one that's a 225 up there. I'm not going to be able to fit that on there. It's really, really steep there at that point. So there's my original function. Now I'm going to do this, right? I'm going to move it. Actually, the vertical typically needs to be the last movement. So we're going to go ahead and do the horizontal. So we're going to move it. Which way? We're going to move it to the right 1. So we're going to move every point to the right 1. Every point to the right 1. And we're going to draw all the new one. I'll draw this one solid. But we're going to make one more transformation, right? So there's the new one. Okay, so that's been completed. Now I'm going to go ahead and put the next one in a black color just to change it up and to see the final answer. So this is now the next thing that I'm doing, which means I'm going to be moving it down 2, right? If it's a vertical adjustment, it's going to go with my intuition. So minus it would seem like it would be moving down, and it does move down. So every point now is going to be moved down 2. All right, and then that 1/3 is going to go down to there. All right, there's my final graph, and I didn't need a graphing calculator. I can use the graphing calculator to confirm it, to verify it if I'm practicing, but I don't need it to graph it. Now let's take a look at where the asymptote would be. Here's my asymptote, right? It's not ever going to reach that place right there, that -2 place, that y equals -2. So let's look at the domain. The domain is -infinity to infinity, and the range is -2 to infinity. All right, we're going to do one. Looks like one more. We're going to start with, again, this reminder. Do you remember back in Algebra 2 when you had a negative in front of the x squared? What did that do to the parabola? Instead of it opening up, you remember, this caused it to open down. Remember that? We're going to do the same thing over here. Do you see this negative out in front of the whole function? That's going to be a reflection in the x-axis. Okay, so now I'm going to now that we have so many different transformations happening, let me give you a little reminder about the order. The order that we need, and the order in which we're going to make transformations, if we have quite a few of them, is this. We're going to take a look at any horizontal, okay, translation. That's horizontal with a plus or minus, right? Horizontal translation. Then we're going to go with any stretching. We haven't talked about that yet, but we'll put it in here. Stretching, shrinking. Actually, I don't think we're going to have that in this. Or reflection. So this is what we're talking about, the reflection. That right there is the reflection. And then lastly, we're going to have any vertical shift. So we're going to go by these steps to make this graph on this time as well. Now the parent graph for this one is this. Let's strip away all the extra stuff, and the parent graph is that. So my parent graph is this right here. I'm going to put that on my coordinate plane. I'm going to have about 1/3. I'm going to have over 0 up 1. I'm going to have over 1 up about 2.7, and I'm going to have over 2 up 7 point something, right? Was that 3, 4, 5, 6, 7 and some? So there's my actual parent graph that I'm going to graph. Notice I really like to have at least 3 points, right? So that I can make my adjustments pretty accurately. Okay, let's take a look. I'm going to first use my horizontal adjustment. Here's my horizontal adjustment. Right here is this right here. We remember it's going to be moving in the opposite direction. So a horizontal adjustment of -3 would normally go to the left, right? Or I would think it would go to the left in the negative direction, but then we know it's going to move it right 3, so I'm going to move my points. Right 3. 2, 3, and 1, 2, 3, and 1, 2, 3 down there. So now there's my, sorry, I'm using black. I meant to use green, but we're fine. Okay, so there's my adjusted horizontal, check. You notice that the next one is going to be a stretch, shrink, or reflection, and in these we're not going to do any stretching or shrinking, so the reflection is going to be next, and that's this thing. It's a reflection in the x-axis, which means that it's going to go right across the x-axis like that. So let's take all of those points and reflect them down, right? Instead of this one here is going to be about here, and instead of this one at 7 point whatever, it's going to be 2, 4, 6, 7 and a little bit here, and then instead of this one here is going to be down there. So let me change my color again. I'm going to go to blue, and I'm going to still keep it a dashed line because we're not finished. Here's my new graph. Now remember, if it's a reflection in the x, it's not going to ever reach the 0, the y equals 0 line, but it's going to get up there closer and closer. Let's take a look at the last one then. We're going to take a look at our vertical transformation, our vertical shift. And the vertical shift is going to happen, it's going to be going up 2, right? Up 2 because it works with my intuition. So I'm going to move all those last blue points up 2. And we're going to cause this last one to be in a solid, dark, bold green line. So where we started with, let's see, up 2. And let's see, everything else is up 2. And then this final one up 2, there's 1 and 2. Now, I got to be kind of careful with this because it's easy to get it all mixed up with the other points, but there is my final answer. And remember, this is going to turn right here and approach an asymptote that is right here, just as if it were the x-axis on the original one. Okay, so my answer, my final answer is that dark green. There it is. All right, I hope this was helpful. Thanks for watching.